Okay, we did one that was exponential decay. Now let's look at 21 here. Okay, 21, this is an exponential growth graph because it's growing as we go left to right. Okay, we want to pick our 2 points. So I'm going to pick my A value or my Y-intercept, which is 0, 2. And remember that 2 is going to be A. And then I've got to find another point. So I'm going to pick 1, 6 right here. So if we go through the process, y equals a times b to the x, we put in our a of 2, and then this is x, this is y, so 6 is equal to 2 times b to the first power. We're putting a 1 in there, and that's x, that's y. So the first step is divide by 2, so 3 equals b to the first. Now if I have b to the first, I don't need to take any root. So I really get just that b is equal to 3. But if that would have been b squared or b to the third, you take the square root or the cube root, whatever you need to do algebraically. So now my equation is y equals a. Well, a is my y-intercept point of 0, 2, or the y value there. So it's 2 times b is 3, so it's going to be 3 to the power of x. And that's an exponential growth graph right there. Okay, so now let's go over to part 1 here. And what we're doing here is solving exponential equations that can be written with the same base. Later in this unit we'll talk about common logarithms and how to do it with logarithms, but we're giving you ones in this that we can write with the same base. So let's look at number 32. So 32, notice I've got 4 to the 3x minus 1 power, and I'm going to make that 16 to the first. And let's zoom in on this a little bit. Okay, I want to take a look at these bases, the things I'm raising to powers, and I want to write them in the same base. Now sometimes one of them can be written, so in other words, this 16 could be written as 4 squared. So I'm going to write that 16 as 4 squared on that side. Now notice 16 was to the first power, so I have 4 squared to the first power. And then on this side I have 4 to the 3x minus 1 power. Now if it's a power to a power, okay, that would be 4 to the 3x minus 1 power equals, power to power I multiply exponents, so 4 squared. Now once I get these two bases the same, I know the bases are the same, so I can basically just set the exponents equal to each other and solve. So 3x minus 1 is 2. I'm going to add 1. So 3x is equal to 3. Divide by 3. X is equal to 1. Okay. Let's go down here where we have to have a number where we change both bases. I'll give you another example here. So for instance, let's look at 33. I'm not going to do this whole problem, but I just want to point out 33. Notice I've got 32 to the negative 3x. I can write 32 and 64 both with a smaller base. They are both powers of 2. You kind of got to recognize, so I could write this as 2 to the 5th, and then that's to the negative 3x power, and I could write 64 as 2 to the 6th, that's going to go inside parentheses, and then I have negative 2x power. Now you have a power to a power, so you're going to multiply exponents. So 5 times negative 3x is 2 to the negative 15x. And here I've got 6 to an outside power of negative 2, so that's 2 to the negative 12x. And then I can set these equal to each other, so I have negative 15x equals negative 12x. And if I've got x on both sides, so I want to get rid of x on a side, so I'm going to add 15x. I'm going to add 15x. So I get 0 equals 3x. I divide by 3. And I get x equals 0. Okay? And so that would be the answer to that one. So sometimes you have to write both numbers with the same base, not being one of the numbers. In other words, smaller than both of the numbers.